Okay, so when we're looking at triangles, inside of triangles, the first step is to make sure we go through and have and label everything that we've been given. So if I look at this, the first thing I notice is that I have angle 1, which is 50 degrees. So I go ahead and mark this measure. This measurement will be 50 degrees. And again, that's angle 1. Angle 2 is given to us as 25 degrees. And B to C. Now B to C is only this portion from here to here. So B to C is 400 meters. And what I have to find here is I have to find AD, and we're going to label AD as just X. And again, A to D is this section in this part of this triangle. All right, now remember, we have to have a right triangle. And that right triangle should have been there in the beginning. So we have two different triangles here. We have the smaller inside triangle, and then we have the larger outside triangle. So let's look at the smaller inside triangle first. So this is 90, this is 50, this is triangle DAB. And again, my final version of this is I need to go through and find X. All right, only thing I can do with this triangle right now is to go through and find the missing angle measurement up here. And if you notice the note, I have a value of 3. This would be angle 3. I find this angle 3 here by knowing that the sum of all of the angles in a triangle have to equal 180 degrees. So this angle is 40. Now, there's something that you have to remember from geometry in order to be able to do this question. And what we need to remember from geometry is what an isosceles triangle is. And the definition of an isosceles triangle is that this side and this side are equal. And when that is true, the two base angles are also equal to each other. And that's really what we have going on over here in this triangle. This is an isosceles triangle. Now, how do I know that? Well, let's take for a second, how would you find out what this angle measurement is here? Well, this entire part is a line. So to find this angle measurement right where the arrow is pointing from here to here, you do 180 minus 50. When you do that, that goes ahead and gives you the fact that this is 130 degrees. So this angle over here, angle 2, as we said in the beginning, is 25 degrees. That's angle 2. So what's left? Well, that is another 25 degree measurement. So what we have here is we have two angles that are 25 degrees, which means across from one side is 400, which means the other side must also be 400. That's the key to this question, because now I know that from D to B, going from here to here, same value, this leg is equal to this leg, so this is 400 as well. It's also 400 meters. Now, as soon as I have that, I can set up my trig ratio. In this piece, you could either use the sine or the cosine, because we have both a hypotenuse and we have two angles. It doesn't matter as long as you are using the correct values. So I'm going to set it up as the sine of 50 degrees. And again, 50 degrees is here. Sine is opposite over the hypotenuse, which gives me that the sine of 50 is x over 400. I chose to use the sine value because that gives me an x in the numerator in the ratio. And to finish this off, I get the fact that 400 times the sine of 50 degrees is equal to x, or that x is equal to 306.4 meters. And I'm rounding it to the fourth because I was told in the beginning to round it to the nearest tenths place.